Hey everyone, this is number 4 from the free response section of the 2019 exam. This is from the no calculator section. And this is just part A. Question says a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve which is not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by dH/dt equals -1/10 square root of h, where h is measured in feet and t is measured in seconds. The volume V of a cylinder with radius r and height h is V equals pi r squared h. Part A asks for the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet and to indicate units of measure. So they are asking you for the rate of change of the volume. And if you would like to pause and think about how you would solve this or what they're specifically asking for, you can go ahead and do that now. They have given you the volume of a cylinder and they're asking you for the rate of change of that volume. So what they're asking you to do is to take the derivative. One thing that is going to make this problem a lot easier is if you notice what's changing in this problem is that the height of the water is changing. It's collecting rainwater, so the height's going up. There's water that's draining out, so maybe the height's going down at some point. But the height of the water is changing, and you can picture that water level going up and down. The radius of that barrel is never going to change. The radius of the barrel is the radius of the barrel. It's not a dimension that can change. So because it is a fixed number or a constant, you would be able to plug in that radius. And I didn't put a unit in, but the radius is 1, right? The diameter is 2. We can see that right here. And so the radius is going to be 1 foot. So the center to the edge, right? So that number is a constant, which means I can plug it in. It's not changing. Then I have a much easier formula that I'm working with, that the volume is pi times the height. So let's go back to what they were asking me to find, the rate of change of the volume, not the volume, but the rate of change of the volume. So I'm going to be taking the derivative. Another thing that you want to remember is that your independent variable is time, because the rate of change, the height is changing with respect to time. So your independent variable is t. You can also see that right here. So if we are taking the derivative with respect to t, the derivative of v is v prime, but on these problems, we were writing it as dv dt, the other notation. Pi is a constant and it can move down, and the derivative of h is h prime or dh dt. Remember the fact that these don't match. That's why we're saying the derivative of h is h prime as opposed to being 1. The derivative of h is not 1 because h is not our independent variable. So we have dv dt is pi times dh dt. And all we have to do is plug in, we have a height of 4. Okay, so this is another good time to pause and think about how are we going to figure out dh dt when the height of the water is 4. And the answer is that it comes from the question. So they gave us in the question stem that dH dt is equal to -1/10 square root of h. And so dH dt, if the height of the water is 4, and I'm getting that from the question, the height of the water is 4 feet. When you plug in 4, you get the square root of 4 is 2, you get -2/10 or -1/5. And so dH dt, that the question gave us the formula for that, when the height is 4, dH dt is -1/5. You could also write that as -pi/5. Finally, they asked for units in this question, indicate units of measure. If you think about volume, think about what the units for volume would be. And I think you guys know that it's a cubic unit, so feet cubed. And then when you take the derivative, remember how we were talking about this towards the end of our meeting time at school? When you take the derivative, you're always dividing by a unit. So I knew it was seconds from the question telling us that time was measured in seconds. So if volume is feet cubed, the derivative is going to be feet cubed per second, because we always divide by a unit when we take a derivative. So I'm going to write feet cubed per second. Looking at the rubric, they give you a point if you were able to take the derivative correctly, and they gave you a point for getting the answer with the units. So you only get that second point if you had the units correct with the answer. And that's it for part A.